All right, so we did the first example. I'm going to go over number three now, because in the first example, we were talking about percentages that we would have taken out of the total. So we were able to just really kind of hone in on looking at the numbers and comparing the numbers from the data table. In this example, we're going to be looking at some conditions. So we are going to actually want to look at percentages in order to make sure that we get the right statement. So let's take a look at number three. When I look at number three, let's start by reading the problem. A child psychologist asked 100 5-year-olds and 50 10-year-olds to name their favorite color. The results are shown in the following table. So if we think about it, the bigger group here is the 5-year-old group. 10-year-olds are out of 50. So we're not looking at evenly sized groups, but if we look at the percentages, that's what we want to compare, right? And that's the choices that are given here in this problem. So let's take a look at the first answer choice. Remember, in these types of problems, you want to go through each answer choice to make sure you get the right one. And we're looking for the one that's true, right? What is supported by the table? That means which one is true. So let's start with answer choice A. All right. Answer choice A says the percentage of 5-year-olds who selected red or blue as their favorite color is greater than the percentage of 10-year-olds who selected red or blue. We're looking at two different groups here, so we actually have to compare their percentages, not the total numbers. And they tell us that in the problem, right? So if we look at this, we're looking at the percentage of 5-year-olds. And then from there, we're looking at the ones that selected red or blue as their favorite. So how many 5-year-olds total do we have? They told us here, or you could add up your numbers and you would get a total of 100. So that's important because that's how we're going to find our percentage, because it's out of 5-year-olds. And then in this group, we wanted the ones that selected red or blue, or meaning they could be one or the other. So we are going to add them together. We see that or in stats, we think addition, because we could have one or the other. So we're going to have those combined. So there's a total of 35 plus 21, red or blue. Okay. And that gets me 56. Okay. But we're looking at a percentage. So I'm going to take that 56 and put that over all 5-year-olds. So 56 out of 100 is 0.56, which is 56%. Okay, so that's important. Let's take a look at what we're comparing it to, because we want to know if this number is greater than the other group. So let's take a look at what we're looking at in the other group. Greater than the percentage of 10-year-olds. Okay, so we're looking at out of 10-year-olds who selected red or blue. Okay, so if we look at the 10-year-old group, they told us that there were 50. We could add up the 10-year-old column and know that there's 50 here. Okay, and we're looking at red or blue. So again, we're going to combine red and blue here. So how many red or blue are there? That's 7 plus 12. Which is 19. Now, if I compared the 56 to the 19, I would already automatically be thinking, all right, well, there's more in the 5-year-old group than in the 10-year-old group. However, we're comparing percentages because the size of the groups are different. So we'll take that 19 and divide that by how many total? 50 10-year-olds total. And that's going to give me something like 0.38. It's an 8. It's supposed to be an 8. Let's try that again. So while I'm looking at these numbers here, is the 5-year-old group greater than the 10-year-old group for red or blue? Well, 0.56 is absolutely greater than 0.38. So this is true. And if I'm super confident, I'm going to just go ahead and answer that because I know that 0.56 is in fact greater than 0.38. It's always good to check your work and go through and answer the other ones, like look at B, C, D, E, right? You would have to get percentages in those as well, but we want to make sure that we're not just looking at the number straight up, but we are actually looking at the percentages like they tell us. Okay?